Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi, Herman and Corin. So I spent a bit of time this morning working on the home desktop, or my desktop, upgrading the CPU cooler, because another interesting use of AI, or one of the best ones, I think I shared in a previous episode that when my home server broke down, I used Claude Code to parse the specs, including what was missing, what was broken, and figure out the best and most affordable way to build it back together from components. And it basically worked. And it wasn't an easy process. Building a computer is quite a labor-intensive process. I think more than labor-intensive, it's just an incredibly precise task. It's literally millimetric precision required for everything, and most of the time was actually spent. It felt like it was wasted, but there's no way around it, on making sure that you're putting in a screw the right way and all that kind of stuff. So the workstation is just to carry on from that, because I said, well, why don't I actually run my workstation through Claude Code? And it told me that my CPU cooler was actually really underpowered, which was maybe why it was running hot. So I figured I may as well finish all these little small upgrades at once. Thankfully, CPU coolers aren't so expensive. They're one of the more affordable components. And I was working on it this morning and struggling again with the same thing, just all these little tiny proprietary screws that had to fit in there. I couldn't get a certain screw off. I know, this is a really exciting episode. But I did eventually so my wife brought out this thing called Leatherman that I didn't even know she had. Her dad gave it to her as a gift. And it is absolutely the most enjoyable screwdriver I've ever used. It got this screw out effortlessly. It felt solid in the hand, and you could even kind of extend it upwards to use it like a screwdriver, even though it's a multi-tool. So what I'd love to talk about today, Herman and Corin, is I mentioned that I want to buy a decent screwdriver set, an ESD mat, maybe a couple of other small things, just because, I don't know, I figured out how to repair stuff myself, and it's very empowering, and it saves a bunch of money. So I figure it's worth buying a couple of things to have a comfortable workspace. So for screwdrivers, we have at home sort of ones that we picked up at the local Mac Stock, which you've talked about is like a budget chain here in Israel, and they're not particularly, you just know they're bad quality. It's like you can just kind of feel, they don't feel satisfying. They tend to thread screws. No, what's the word when they take off the metal? You know, when they scrape it off. They do that very easily, which can damage screws, and then you have to get them out through more complicated methods. Anyway, Herman and Corin, if you look for a precision screwdriver set, the kind that would be really useful for electronic repairs, and I presume for this particular task, we want stuff that is ESD-safe or anti-static and magnetizing. I've seen that those little things that magnetize and demagnetize screwdrivers are available. I wonder actually, are there ones that have a little switch where you can turn it on and off? Because sometimes when you're trying to drop a tiny screw into a motherboard, the magnetizing thing is brilliant, but then at the very end you need to get it to release. And I don't know, is there a way to do it? Like, can you have one that has a little switch? Anyway, Herman and Corin, the main thrust of my question today is trying to buy a quality precision screwdriver set. What are we looking for exactly? I'm always wary of anything, not just on AliExpress, but anywhere in general, that they try to sell you everything all at once. It's like, here's every single screwdriver and every screw while we're at it in this gigantic box. And usually the components end up being pretty bad. So my focus would be on finding whatever is necessary for computer repairs. Think about stuff like T20 heads, M2s, M3s, and getting it at weird angles. That's the other thing that I always becomes really hard when you're working on in a very confined space like a desktop computer. You open it up and you're trying to get a screw to release a socket without having to take all of the RAM sticks out or something like that. And if you can just slot something in laterally and screw, you think that would be amazing. But with a straight screwdriver, it's not easy. Anyway, you get the idea, Herman and Corn. What would you recommend? Specific brands, specific screwdrivers, and magnetizing instruments for a good and high quality precision screwdriver set for those into electronics? Herman and Corn, over to you.
Hey everyone, and welcome back to my weird prompts. I am Corn, and I am joined as always by my brother,
Herman Poppleberry, at your service. And today we are diving into the world of precision engineering, or at least the tools that make it possible for us mere mortals to interact with it.
It is funny you say that, because Daniel's prompt today really hit home for me. He has been working on upgrading his CPU cooler, which sounds like a straightforward task on paper. You buy the cooler, you apply the thermal paste, you screw it down. But it is never that simple, is it? You describe being 3 inches deep into a dark computer case, trying to reach a mounting screw that seems determined to strip itself out of existence.
The struggle is real, Corn. There is nothing quite like that sinking feeling in your gut when you feel the screwdriver tip slip just a tiny bit. It is that tactile pop followed by a gritty sensation, and you know instantly that you have just rounded off the edges of a tiny proprietary screw. It is the stuff of nightmares for anyone who enjoys tinkering, because once that head is gone, you are looking at a very stressful afternoon with a drill or a pair of needle nose pliers.
Exactly. Daniel is tired of the bargain bin experience. He is looking for the good stuff. He wants a professional-grade precision screwdriver set, an electrostatic discharge mat or ESD mat, and some real-world solutions for those tight, awkward spaces inside a desktop. He specifically mentioned T20, M2, and M3 heads, and he is tired of low-quality tools that do more damage than good.
I love this topic because it is one of those areas where spending a little more money up front saves you an incredible amount of frustration and potentially hundreds of dollars in damaged components later. When you are working on a motherboard or a high-end graphics card, the margin for error is essentially zero. One slip can sever a trace on the PCB, and suddenly your $2,000 rig is a very expensive paperweight.
So, let us start with the big question, Herman. Why do cheap screwdrivers strip screws? I think most people assume it is just their own fault, like they did not push hard enough or they had the wrong angle, but there is a lot of actual physics and material science involved here, right?
Oh, absolutely. It really comes down to 2 main factors, tolerances and metallurgy. Let's talk metallurgy first. Cheap screwdriver sets, like the ones you might find at a checkout counter or in a generic home toolkit, are often made of soft, low-grade carbon steel. When you apply torque to a stubborn screw, the metal of the screwdriver tip actually deforms. It is softer than the screw itself sometimes. Once that tip loses its sharp, precise edges, it can no longer grip the screw head properly.
And that is where the slipping happens.
Right. We call that cam out. It is especially common with Phillips head screws because, believe it or not, they were actually designed to cam out. Back in the early industrial days, they wanted the tool to slip out of the screw to prevent over-tightening on assembly lines. But in precision electronics, you want the exact opposite. You want a perfect, snug fit. High-quality tools use much harder alloys, like S2 tool steel or chrome, vanadium molybdenum steel. These materials are heat-treated to a specific Rockwell hardness, usually around 58 to 62 HRC, so they can withstand that torque without deforming.
And then there is the tolerance issue you mentioned. I am guessing that is about how well the tool actually fits the hole.
Exactly. If the screwdriver tip is even a tenth of a millimeter off in its dimensions, it is not sitting flush. That tiny gap is all it takes for the force to be concentrated on the very tips of the corners of the screw head instead of being distributed across the whole surface area. A professional-grade tool from a brand like Weha or Wera is machined to incredibly tight tolerances. When you put a Weha Phillips 00 into a high-quality screw, it almost feels like they are magnetically locked together even before you apply a magnet. It is a mechanical seat that feels solid.
That is a great point. Daniel mentioned M2 and M3 heads, but I think we should clarify something for the listeners. M2 and M3 actually refer to the metric thread size of the screw, not the drive type.
Good catch, Corn. This is a common point of confusion. An M2 screw means it has a 2 mm major diameter on the threads. Usually, an M2 or M3 screw in a computer will have a Phillips number 0 or a Phillips number 1 head. Sometimes you will see them with a small hex or Torx drive, especially in laptops or high-end cases. For a desktop computer, you are mostly looking at Phillips and Torx. The T20 he mentioned is a Torx size, which is that 6-pointed star shape. Torx is actually much better than Phillips because it is designed specifically to prevent cam out. It can handle much higher torque without slipping because the sidewalls of the drive are vertical.
So if someone is looking for that professional grade set Daniel asked about, where should they start? Everyone knows iFixit, but are they truly the top tier, or is there something even better?
iFix. It is excellent, especially for the price and the sheer variety of bits you get. Their ProTech toolkit is basically the industry standard for hobbyists and many professional repair techs. They use S2 steel, and their bit driver has a great feel with a ball-bearing swivel cap. But if you want to go one step further into the buy it for life category, the kind of tools that professional German engineers use, you start looking at brands like Wiha, Wera, and PB Swiss.
I have seen the Wera sets. They have those very distinct ergonomic handles that look almost like a piece of modern art. They are yellow and green, or black and green, right?
Those are the ones, the Craftform micro handles. They are designed with different zones. There is a fast-turning zone at the top for when the screw is loose and you just want to spin it quickly. Then there is a power zone in the middle for applying torque, and a precision zone right near the blade for fine adjustments. It sounds like marketing speak, but when you are trying to loosen a tiny screw in a cramped space, having that specific grip geometry really matters. It prevents your fingers from cramping up and gives you much better control over the downward pressure.
And what about Wiha? I feel like I see their name mentioned in every high-end tool forum.
Wiha is often considered the gold standard for precision. Their Pico finish line is incredible. The handles are a bit slimmer than Wera's, which some people prefer for very delicate work where you need to feel every tiny vibration. Their steel is legendary for its durability. If you buy a Wiha set, you are probably still going to be using it 20 years from now. For Daniel's needs, specifically working on desktops, I would actually recommend looking at a set that includes some longer blades.
That leads perfectly into his question about confined spaces. A standard precision screwdriver is usually only a few inches long. If you are trying to reach a mounting screw behind a massive CPU air cooler or down near the power supply shroud, your hand is going to be in the way. You can't even see what you're doing.
This is where bit extenders and flexible shafts come in, but you have to be careful. The iFixit set comes with a flexible extension, which is okay for light work, but for a desktop I prefer a rigid long-reach driver. You can get Wiha drivers with 6-inch or even 8-inch shafts. If you are working in a deep case, that extra length is a lifesaver because it keeps your hand and the handle outside of the danger zone of the components. You have a clear line of sight to the screw.
Daniel also asked about a switch for magnetization. He mentioned that sometimes you want the screw to stay on the tip, but other times you need it to release easily so it doesn't get pulled toward a nearby magnet or component. I do not know if I have ever seen a screwdriver with a physical toggle switch for magnetism. Is that a thing?
Not in the way he is imagining, like an electromagnet with a button. That would be cool, but it would be bulky and require a battery. What we use instead is a magnetizer/demagnetizer block. It is a little plastic cube with 2 openings. You slide the screwdriver blade through one opening to magnetize it, and you rub it against the steps of the other opening to demagnetize it.
How does that actually work? It feels like magic every time I do it. I remember doing it in middle school science class and being blown away.
It is all about the alignment of magnetic domains within the steel of the screwdriver. When you pass it through the strong permanent magnet in the magnetizer, it aligns those domains in one direction, turning the blade into a temporary magnet. The demagnetizer uses a specific magnetic field geometry to scramble those domains back into a random orientation. It takes about 2 seconds to do. So while it is not a switch on the handle, it is a very quick manual process. Most professional sets will actually come with one of these blocks.
That is definitely a must-have. I can't tell you how many times I have dropped a screw into the bottom of a power supply or under a motherboard. Without a magnetized tip, getting those back out is a nightmare. But, as Daniel noted, you have to be careful. You do not necessarily want a strong magnet right next to certain components.
Exactly. While most modern computer components are fairly resilient to small magnets, you still want to be cautious around things like traditional spinning hard drives or certain sensitive Hall effect sensors. Being able to demagnetize the tool instantly is a huge advantage. It gives you total control over the environment.
Let us talk about the electrostatic discharge safety. Daniel specifically asked for an ESD-safe set and a mat. I think a lot of people skip the mat because they think as long as they touch the metal case of the computer every few minutes, they are fine. Is that true, or is that just an urban legend?
It is a better than nothing approach, but it is definitely not professional grade. Static electricity is a silent killer for electronics. You can fry a component with a discharge that you cannot even feel. A human can generally only feel a static shock if it is over 3000 volts. But a CMOS chip can be damaged or degraded by as little as 30 volts.
30 volts? That is nothing. That is like a fraction of a battery.
Right. So you might be zapping your motherboard every time you touch it and never even know why the computer starts acting flaky 3 months later. You think it's a software bug, but it's actually physical damage from a static event. An ESD-safe screwdriver has a handle made of dissipative material. It is designed to bleed off any static charge at a controlled rate, so it doesn't jump all at once in a spark.
And the mat? How does that fit into the system?
The mat is the foundation of a safe workspace. A good ESD mat is usually 2 layers. The top layer is dissipative, and the bottom layer is conductive. You connect the mat to a known ground, like the center screw of a wall outlet or the grounding pin of a plug using a special adapter. Then, you wear a wrist strap that is also connected to the mat. This ensures that you, the tool, the mat, and the computer are all at the same electrical potential. No potential difference means no sparks, no zaps, and no dead motherboards.
For someone like Daniel who is doing this at home, what should he look for in a mat? I see those cheap blue folding ones online all the time for $10.
Avoid the cheap PVC folding ones if you can. They tend to curl up at the edges, they smell like chemicals, and they do not always have great dissipative properties over time. Look for a real rubber mat. They are heat resistant, so if you ever decide to do some soldering, you won't melt your workspace. Brands like Bertec or Hakko make excellent professional mats. They are a bit of an investment, maybe $50 to $80, but again, they last forever and they actually work.
One thing Daniel mentioned that I found interesting was the idea of working at weird angles. He mentioned getting a screw to release from a socket without having to take out all the RAM sticks. A straight screwdriver can't do that because the handle hits the other components.
That is where the bit ratchet comes in. This is one of my favorite tools for desktop repair. It is a tiny, low-profile ratchet that holds standard 4mm or 1/4-inch bits. Wera makes a beautiful one called the Zyklop Mini. It is only about 3 inches long and very thin. You can fit it into gaps where a screwdriver handle simply won't go. You can use your thumb to spin the dial for quick movements and then use the ratchet handle for torque.
I have used those. They are amazing for getting at those motherboard mounting screws that are tucked way up in the top left corner of the case, right under the big VRM heatsinks.
Exactly. If you combine a bit ratchet with a set of high-quality bits, you are prepared for almost anything. And for those really weird lateral angles, you can even get offset screwdrivers, which are shaped like an L, but those are less common in precision sizes. The ratchet is usually the better bet for a PC builder.
So, if we were to build Daniel a dream kit based on his prompt, what is on the list? Let's get specific.
Okay, let's break it down. First, for the main drivers, I would go with a Wiha Pico Finish ESD set. Specifically, he should look for the set with the yellow and black handles. That yellow signifies it is ESD safe. He should get a set that covers Phillips 000 and 1 plus torque sizes from T5 up to T20. That will cover 99% of what he finds in a desktop or a laptop.
And what about those M2 and M3 sizes he was worried about?
Since those are usually Phillips heads, the Phillips 0 and 1 from that Wiha set will cover them perfectly. But for a desktop, I would also add a couple of nut drivers in metric sizes, specifically 4mm and 5mm. Sometimes motherboard standoffs or hex head screws are used, and a nut driver is much more secure than trying to use pliers.
Second item on the list.
The Wera Mini Bit Ratchet. It is a game changer for tight spaces. I would pair that with a good set of precision bits, maybe from iFixit or Weha. Having both a dedicated driver and a ratchet gives you the best of both worlds.
Third,
A high-quality rubber ESD mat, at least 24 by 36 inches, so he has plenty of room to spread out. And don't forget the grounding cord and the wrist strap. That is the most important part. If you aren't grounded to the mat isn't doing its job.
and fourth?
A standalone magnetizer-demagnetizer block. Weha makes a great one, but even the generic ones work fine for this. And I'd throw in a pair of ESD-safe tweezers. When you are working in those confined spaces, sometimes you can get the screw loose, but you can't get your fingers in there to pick it up. A pair of long, curved ESD tweezers is the perfect companion.
That sounds like a solid professional setup. It is definitely a step up from the budget sets he mentioned. You know, I was thinking about what he said about the Leatherman his wife gave him. He said it was the most enjoyable screwdriver he had ever used. Why do you think that is?
Leatherman tools are surprisingly good for what they are. They use a proprietary flat bit system which is very strong and the reach is decent. But the real reason he probably liked it is the heft. A lot of cheap precision tools feel like toys because they are so light and hollow. A tool with some weight and a solid mechanical click feels more reliable. It gives you confidence. But for delicate electronics, you really want that specialized precision handle. You need the feedback. You want to feel exactly how much resistance that screw is giving you so you don't over-torque it.
That feedback is so important. When you're screwing into plastic or a thin aluminum standoff, it is so easy to strip the threads if you can't feel the tension.
Precisely. That is actually another feature of high-end tools. The handles are designed to give you better tactile feedback. If you are using a cheap, thick plastic handle, it absorbs all those subtle vibrations. With a thin, high-quality precision handle, you can actually feel the bite of the threads. It is the difference between driving a sports car and driving a bus.
We have talked a lot about the tools themselves, but I think we should touch on the technique too. Daniel mentioned he's been struggling with damaging screws. Even with the best tools, you can still strip a screw if you don't use them correctly.
That is a great point, Korn. The number one rule is downward pressure. Most people try to turn the screwdriver with all their strength, but only push down lightly. You should actually be putting about 70% of your effort into pushing the tool into the screw head and only 30% into the rotation. This keeps the bit seated and prevents cam out.
And the back turn trick. You taught me that years ago, and it changed my life.
Oh yes. If you are starting a screw, especially in a delicate hole like a motherboard standoff, turn it backward, counterclockwise until you feel or hear a tiny click. That is the start of the screw thread dropping into the start of the hole thread. Once you feel that click, then you start turning it forward. This prevents cross-threading, which is the fastest way to ruin a motherboard.
I remember learning that the hard way years ago. It feels so counterintuitive to turn a screw the wrong way first, but it works every time. It's like finding the key to the lock.
It is a lifesaver. Another tip for Daniel is to stay organized. When you are taking apart a desktop, you end up with 20 different screws of 5 different sizes. If you put an M3 screw into an M2 hole, you are going to have a bad time. You'll strip the hole out and the screw will be stuck.
I usually use a magnetic parts tray, but Daniel mentioned he wants to be ESD-safe. Are those magnetic trays okay for this?
They are generally fine for the screws themselves, but you don't want the tray sitting on top of your motherboard or right next to your SSD. A better solution for a professional workspace is an ESD-safe organizer or even just a piece of paper where you draw a diagram of the computer and tape the screws to their corresponding locations.
That is a classic move. I have seen people take a photo of the case, print it out, and then just poke the screws through the paper at the right spots. It's low-tech, but it works perfectly.
It is brilliant because it is foolproof. You don't have to remember which screw went where 3 hours later when you are finally putting it back together. It's all about reducing the cognitive load so you can focus on the delicate work.
So, we have covered the brands, Weha, Wera, and iFixit. We have covered the materials, S2 steel and dissipative handles. We have covered the ESD mats and the magnetization. Is there anything else Daniel should be looking for?
Maybe a small, bright LED flashlight or a headlamp. Computer cases are dark, and even in a well-lit room, shadows from the CPU cooler or the GPU can make it impossible to see if your screwdriver is actually seated in the screw head. If you can't see the screw head clearly, you are much more likely to slip and damage it.
A headlamp is a total game changer. It keeps both of your hands free for the tools. I actually prefer it over a flashlight because the light follows your eyes.
Exactly. And one last thing, if he ever encounters a screw that is already partially stripped, he can try the rubber band trick. You place a wide, flat rubber band between the screwdriver tip and the screw. It fills in the gaps and provides extra grip. It doesn't always work, but it's a great Hail Mary before you break out the power tools.
This has been a great deep dive. I think it is easy to dismiss tools as just stuff, but when you are doing precision work, the tool is the interface between your brain and the machine. If that interface is sloppy or weak, the work is going to suffer.
Well said, Korn. It is about respect for the craft. If you are going to spend hundreds or thousands of dollars on high-end components, it only makes sense to spend $50 or $60 on the tools you need to install them safely. It's an investment in your own peace of mind.
Exactly. And Daniel, if you are listening, definitely go for the Weha Pico Finish ESD set. It sounds like exactly what you need for that professional feel you are looking for. It's a joy to use.
And get the mat. Do not skip the mat. Your motherboard will thank you, and you'll sleep better knowing you didn't accidentally zap your hardware.
Well, I think that covers it for this one. If you've been enjoying the show, we would really appreciate a quick review on your podcast app. It genuinely helps other people find us and keeps the show growing. We've been doing this for a while now, and the community support is what keeps us going.
It really does. We love seeing the feedback and hearing about the projects you all are working on.
You can find us on Spotify, Apple Podcasts, and pretty much everywhere else you listen to podcasts. Our website is myweirdprompts.com, where you can find our full archive of over 600 episodes and the contact form if you want to get in touch with your own questions.
And you can always reach us directly at show@myweirdprompts.com. We read every email.
Thanks for listening to My Weird Prompts. We will be back soon with more of your questions and ideas.
Until next time.
Goodbye, everyone.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.